Have you ever looked at a plastic water bottle? Or a rubber band? Or even your own hair? You are looking at polymers. They are everywhere. It sounds like a big, science-y word, but the idea is actually pretty simple. Polymers are just very, very long chains made of smaller parts, linked together. Think about it like a long train. The train is the polymer. Each train car is a smaller part, a monomer. Mono means one, mer means part. So a monomer is one single part. Link many monomers together and you get a long repeating chain, a polymer. Poly means many, so a polymer is literally many parts. Imagine a huge box full of paper clips. One paper clip is like a monomer. Start linking them, one after another. You can make a super long chain. That chain is your polymer. It can be flexible. It can be strong. And it's made from simple, repeating units. That's the big idea. Back to the plastic bottle. The plastic itself is a polymer. It's made of countless tiny monomer molecules. So, how do these tiny monomers actually link up to become a big polymer chain? It's a process called polymerization, and it's like building with Lego bricks. You take one brick, a monomer, and click another one onto it. Then you click another one, and another, and another. The chain gets longer and longer with each new piece you add. This process happens on a chemical level, where molecules bond together. The monomers are the building blocks, and the chemical reactions are the clicks that connect them into a sturdy structure. There are two main ways this happens. The first one is called addition polymerization. This is exactly what it sounds like. Monomers just keep adding on to the end of the chain. Imagine a conga line at a party. One person starts, then another joins, and the line just gets longer and longer. Nothing is lost, the chain just grows. Polyethylene, the plastic used to make grocery bags and food containers, is made this way. Many ethylene monomers just add to each other, one by one, to form a very long chain. The other main method is called condensation polymerization. This one is a little different. When two monomers join together in this method, a tiny molecule, usually water, gets squeezed out or released. Think of it like two people holding hands, and when they do, a drop of water falls to the ground. That's why it's called condensation, like when water droplets form on a cold glass. For the chain to grow, every time a new monomer link is made, a tiny bit of water is left behind. Nylon, which is used for ropes and fabrics, is made this way. No matter which way they form, the result is a long, chain-like molecule with incredible properties. The length of the chain and the way the chains tangle up with each other determine how the final material will behave. Are the chains straight and packed tightly? You might get a strong, rigid plastic. Are they loose and tangled like a bowl of spaghetti? You might get a soft, flexible material. It all comes down to the chemistry of those tiny links and how they come together to form the bigger picture. As we saw, nature is a master of polymers. Let's look a little closer. DNA proteins, think about a tree. The wood that makes a tree strong and tall is mostly made of cellulose. Cellulose is a polymer made from a sugar monomer called glucose. Plants link up thousands of glucose units to create these incredibly strong fibers. Cotton is almost pure cellulose, which is why your cotton t-shirt is both soft and durable. Even the starch in potatoes and bread is a polymer, also made of glucose, but linked in a different way that our bodies can easily break down for energy. Rubber is another fantastic natural polymer. It comes from the sap of a rubber tree. In its natural form, it's sticky and not very useful. But people learned how to treat it with heat and sulfur in a process called vulcanization. This creates extra links between the polymer chains, making the rubber strong, stretchy, and waterproof. That's why we can use it for tires. So why are these long chain molecules so popular? Well, it's because they have a fantastic combination of properties that are hard to find in other materials, like metal, wood, or glass. One of the biggest advantages is that most polymers are lightweight. A plastic car bumper is much lighter than a steel one, which helps make cars more fuel efficient. A plastic bottle is much lighter than a glass one, making it easier to carry and cheaper to transport. This lightness is a huge benefit in everything from aerospace engineering to packaging. On top of being light, many polymers are also incredibly strong and durable for their weight. Think about a climbing rope made of nylon or a helmet made of polycarbonate plastic. These materials can withstand huge amounts of force without breaking, keeping people safe. They don't rust like metal, and they don't rot like wood. This resistance to decay is why polymers are perfect for things that need to last a long time, like underground water pipes or the siding on a house. They can handle a lot of wear and tear. Another amazing thing about polymers is their versatility. You can make them soft and stretchy like a rubber glove. You can make them hard and rigid like a Lego brick. Now we have to talk about the flip side. That same durability that makes polymers so useful also creates a huge problem: waste. Most synthetic polymers, especially plastics, are not biodegradable. That means that microorganisms in the soil or water can't break them down. The plastic bottle you throw away today could still be sitting in a landfill or floating in the ocean hundreds of years from now. It's a bit like building something that is designed to last forever, and then just tossing it aside after using it once. All of this plastic has to go somewhere. Every year, we produce hundreds of millions of tons of plastic, and a huge chunk of it is used for single-use items like bag straws packaging. A lot of this waste ends up in our environment. So, polymers are amazing, but they also create a big challenge. What can we do about it? The answer starts with small, simple actions that, when added together, can make a big difference. It's just like how monomers link up to create a strong chain. The first and most powerful step is to reduce the amount of single-use plastic you use. Instead of buying water in a plastic bottle, carry a reusable one. Say no. Thank you to plastic straws, and bring your own reusable bags to the grocery store.